Okay, I know I rushed 6.1 and 6.2, but 6.3 and 6.4 are basically the same. This whole chapter 6, we're going to spend some time in class just practicing problems, okay, without me really teaching a lot. I want you guys to solve equations. We'll just be solving them together in class, okay? So that'll give us lots of time for you to practice. Let me just go through the difference between the types of equations we're doing this chapter. Um, okay, basically, look at the equation. I think you'll see that we're taking the sign of half x instead of just the sign of x. That just makes it a little different. But again, guys, we're just trying to find x. Okay, so do all the things that you would have done in a normal algebraic equation. Don't second guess yourself. Okay, a lot of times you guys know how to start, but you're not sure because it's trig. You think you might have to do something different. Okay, so basically we would divide both sides by 2, right? Okay, and then we want to undo the sign. So we want to take the sine inverse of both sides. So I have x over 2 equals the inverse sine of a half. And just think to yourself what that means. That means what angle do I take the sine of that gives me a half? Okay, over the interval from 0 to 2 pi. Okay, so you either have to look it up on your unit circle, that's fine, or you stick it in the calculator, which remember won't actually give you, it'll give you a clue, but it doesn't always give you the exact answer. If you do inverse sine of a half on your calculator, you get negative, if you're in degree mode, negative 30 degrees. We want it from 0 to 2 pi. Okay, so you just think, okay, well, oh no, never mind, it's positive a half. It'll give you 30 degrees. So then that's great. That's one of the answers is 30 degrees or pi over 6, but it doesn't give you the other answer. You have to think to yourself that there are 2 places where the sign is a half, right? At pi over 6 and also at 5 pi over 6. Okay? Well, that's great. That's what x over 2 is. We don't want what x over 2 is. We want x, so just multiply both sides by 2. You get 2 pi over 6, which is pi over 3, or if you multiply this side by 2, you get 10 pi over 6, which is 5 pi over 3. Okay? That's if it's over the interval 0 to 2 pi. Those are our answers, right? Now, let's try for all solutions. If we want for all solutions, this x over 2 ends up, last chapter we just did plus 2 pi n and plus 2 pi n every time, right? Unless it was tangent, we did plus pi n. So here, what I always have kids do is just do the same thing we just did. X over 2 equals pi over 6 plus 2 pi n, or x over 2 equals 5 pi over 6 plus 2 pi n. So that we remember that we're multiplying, when we multiply by 2, we also have to multiply the 2 pi n. So I get pi over 3, just like I did over here, plus I'm also multiplying the 2 times the 2 pi n. It's plus 4 pi n, or 5 pi over 3 plus 4 pi n. Don't put plus 2 pi n, okay? Because since it was half of x we were adding 2 pi n to. Once you multiply by 2, you have to multiply the 2 pi n by 2 as well. Okay? All right. Try this one. Cosine of 2x equals cosine x. Again, we're doing these different things. With last chapter was more just we were doing the trig identity of an angle, x, not half x, not twice x. Okay, so that's the difference here. All right, we really, it's tough to solve a problem when the angles that you're taking the cosine of are different. Okay, so let's look at cosine of 2x. Get your identities out and look at what all the things that cosine 2x equals. We have cosine squared minus sine squared. We have 1 minus 2 sine squared. We have 2 cosine squared minus 1. Okay, and since the other thing in our equation is using cosine x, then that's what I'm going to choose for, which 3 should I choose from? I'm going to choose the one that has cosine x only in it. Okay, so cosine of 2x, I'm going to write 2 cosine squared x minus 1 from my identity sheet. Okay, anytime I have something squared, and I mean, it's just the same as a quadratic, okay, in algebra. Let's set that equal to 0. All right, if you have to, sometimes I go off to the side and I think, what would I do if it was an algebra equation where I have 2 times something squared minus that something minus 1. And I know that I would factor that as 2x plus 1, x minus 1, I guess. 2x squared, yeah. All right, so that's what I'm going to do here, except instead of x, it's cosine x. So 2 cosine x plus 1 times cosine x minus 1. Okay, notice if you FOIL it, you get 2 cosine squared minus 2 cosine plus 1 cosine is minus 1 cosine and minus 1. Set each of these equal to 0, and we have a little, 2 little problems that are like 6, 1 and 6, 2. 2 cosine x equals negative 1. Cosine x is negative a half. So x is going to be the inverse cosine of negative a half. And here x is the inverse cosine of 1. So I'm thinking I was supposed to go from 0 to 2 pi. What angle do I take the cosine of? And it gives me negative a half. So I know I'm over here in the second and third quadrant. I know I'm thinking pi over 3, but over in the second and third quadrant, that would be 2 pi over 3, or down here, what's that, 5 pi over 3? Oh no, I'm sorry, 4 pi over 3. 2 pi over 3, 4 pi over 3. Where is the cosine equal to 1? Is that 0 and 2 pi? Right? It starts, sometimes I think unit circle, sometimes I graph it in my head, and I'm like, oh, it was positive 1 at 0 and 2 pi. So I have 4 different answers for this one. 0, 2 pi over 3, 4 pi over 3, and 2 pi. Okay? Oh, gracious. I wasn't including 2 pi. I wonder why. Oh, well. Be careful with that. It's actually just 0, 2 pi over 3, and 4 pi over 3. Since in the directions it said to solve over the interval including 0 to 2 pi, but not including 2 pi. Sometimes they do that just to torture us. Okay, let's try this one. Ooh, we have sine and cosine together. Never good. Never, ever good. It's hard to separate when we have sine and cosine together. Not even equal to 0. Ugh. Like right now, my gut instinct, of course, we want to have it set equal to 0 because then we can factor. But I need something that just has sine or just has cosine. So look on your identity sheet, okay? And I think you'll see the sine of twice an angle is 2 sine cosine, right? So wouldn't 2, I can multiply both sides by 2, and then 2 sine of twice an angle is 4 sine cosine. right? Let's do that. 2 sine of twice an angle is exactly the same as this. We see it on our identity sheet. The reason I'm doing that, again, is so that I just have one trig function. I don't want all these trig functions. I don't want sine and cosine together if I can help it. You'll always be able to have that formula sheet by you guys, okay? And now I'm just gonna, oh, well, that was silly. Now I didn't really need to do the, I'm not actually factoring. I only have one trig function here. So I'm gonna put my square root of 3 back where it was. I'm gonna divide by this 2 in front. Oh, yay. So twice theta is the inverse sine of the square root of 3 over 2. So what angle do I take the sine of to give me square root of 3 over 2? Oh, we're doing 0 to 360. So now I'm in degrees. Goody. Well, I'm square root of 3 over 2. What is it, 60 degrees? Because 30, yeah, 60 degrees. So twice theta either equals 60 degrees or twice theta equals, where else am I positive? Over here at, would that be 120 degrees? Okay, does that make sense? Okay, so then I would divide by theta. Oh no, divide by 2, I guess. Oh, let me see. Oh, this is twice theta though. Let me think here. Let's do it for all solutions first. Okay. So I have twice theta equals 60 degrees plus, I'm not going to say 2 pi n. That's right. This is degrees. 60 degrees plus 360 n, or twice theta equals 120 plus 360 n. And then I'm going to divide by 2 to get theta equals 30 plus 180 n, or theta equals 60 plus 180 n. Okay? And what happens, guys, is, because see, if I would have stopped right here, I would have at least gotten my 30 and I would have gotten my 60. And then I should have realized then, and I did as I was doing it, that's only going to give me 2 angles in the first quadrant. I know there's other angles that will work now that I cut this in half. So sometimes I use this to generate all my angles. Like 30 plus, what's 30 plus 180? 30 plus 180, 210. What's 60 plus 180? 240. What's, keep going, you know. If I add another 180 to 210, oh, okay, that gives me 390, so I'm above 360. I wanted all the answers from 0 to 360. So sometimes when there's twice an angle, this quick formula will just give you a couple, but you have to think about the fact that it was twice an angle, so you want all the angles that work. So I usually, even if this wouldn't have said for all solutions, I would have done it for all solutions just to get those extra ones. This generates them all. Okay, this will give me all of them. So I use them to help me find all of them from 0 to 360. 30, 60, 210, 240. Okay, let's try this one. Okay, guys, I only have 40 seconds here. So I'm going to show you a strategy that works for these and just put the work up so you can study it, okay? Sometimes we need to square both sides of an equation so that, because the only thing that I have that relates tangent and secant are some squares. Okay, so square both sides. I subtracted secant and now I'm squaring both sides. You do that, you have to FOIL this out, okay? Replace tangent squared 3x with secant squared 3x minus 1. Secant squareds cancel then, and you have a simpler equation. These are approximations that you get on your calculator.